Okay, relations and functions. Functions. So fun. Okay. So a relation is a set of ordered pairs. So there are different ways of representing relations. An example would be like the ordered pair -1, 0, 4, 2, 9, 7. That's an example because that's a set of ordered pairs. Another way of doing it would be a table. So that would be like 5, -3, 6, 2, 7, 0, 8, 4. Those are all pairs. You could do it by mapping. So like your x values are on the left, your y values are on the right. A graph, you can have all those points there. Or it could be an equation. So y equals -3x squared plus 7. Okay, and now our domain, that's the set of x values. That has always been the case for domain. You guys should remember that from previous math courses. And the range is the set of y values. Okay, so let's get into this. We want to give the domain and range of each relation. So the domain, remember, is your x values. The range is your y values. So in this first one, my domain is, or my x values are -1, 7, 3, and -5. My y values are -1, 4, 0, and -1. So my domain, I'm just going to put it from least to greatest, is -5, -1, 3, 7. My range is -1, 0, 4. Okay, and the second one, I'm going to write out all those points. So I have -3, -4, -1, 5, 1, 2, and 1, -3, and 2, 0. So my domain is -3, -1, 1, and 2. My range is -4, -3, 0, 2, and 5. Okay, for this last one, my domain is 2, -1, 0, 1, and 2. My range is 0, 1, and 4. Now we need to give the domain in set notation. Okay, so set notation, I don't know if you guys have seen set notation before. So I'm going to go through this a little bit slower. Set notation, here I'll give you a little brief introduction. Let's pull up a chalkboard. So set notation, that's like x such that x is greater than or equal to whatever your y value, or whatever it's greater than or equal to. Say it's 2. Or it could be x such that x is greater than 3 and less than or equal to 7. Okay, so it's always x such that, and then whatever this happens to be. Okay, so let's do an example of this. How do I get rid of this? Erase all strokes. Okay, so say you have this graph here. And if we go back 1, 2, 3, let's go back to -3. And this is going to be our graph right there. We need to write the domain for this. So my domain here, well, the smallest x value this is -3. So x is greater than or equal to -3, right? My range here, the smallest it gets is 0, so it's going to be y is greater than or equal to 0. Well, you're already halfway done with this set notation stuff. So the only thing you have to add on the domain is this squiggly bracket, x, such that x is greater than or equal to -3. The range, same thing, just add the squiggly bracket, y, such that y is greater than or equal to 0. Okay, I'll go over that a little bit more in class. Hopefully that helps clear up some confusion. Let's look at this. So my domain on this one is all real numbers. So if it's ever all real numbers, like it goes from -infinity to +infinity, just write, I don't think that's the correct R. It's more like this. That's why it's not showing up. Okay, it's more like this. The R with 2 lines. That means all real numbers. All real numbers. Okay. Now my range here, it looks like the highest this gets is 1, 2, 3, 4, 5, 6, 7, or 6. Yeah, 6. So it's y such that y is less than or equal to 6. Okay, let's look at B. So my domain here, the smallest this gets is -3. So this is x such that x is greater than or equal to -3. My range is y such that y is greater than or equal to -4. Now this last one is x such that x cannot equal 3 because it equals every other number except for 3 because there's an asymptote right there. Sorry. My range is y such that y cannot equal 0. Okay? Now let's look at this. So give the domain an interval notation. So interval notation is, let's go through this again. So interval notation, say we have that same exact graph. So we have this graph right here. We went back 1, 2, 3, and it went up right there. Interval notation, we're going to write in intervals. So the smallest x value this gets is -3, and it equals -3, so that's going to be a bracket. And it's going to be -3 to infinity. For my range, the smallest this gets is 0, so that's going to be 0 to infinity. Okay? And you can do lots of different ways. Well, not lots of different ways. If it's equal to, it's a bracket. If it's not equal to, it's a parenthesis. Okay, and on the infinities, you never have brackets. It's always a parenthesis because you can't really equal infinity because there's always a number bigger. Okay, so my domain on A is -infinity to +infinity. My range is -5 to +5, and those are both included, so they're both brackets. Okay, on this next one, my domain is -infinity to -1, and then that U just basically means or -1 to infinity. Or and -1 to infinity. Okay. My range, -infinity to -3 and -3 to infinity. This last one, my domain is -4 to 1 and it's a parenthesis on -4, closed on 1. My range is -7 to 2. Okay, now let's get a little bit more into functions. So a function is a special type of relation in which each element of the domain is paired with exactly one element of the range. This means that each x value goes with exactly one y value. An x value cannot, or a y value cannot go to two x values. Okay? So if we're looking to see if this is a function, sorry, I got distracted. With that -9 on this first one goes to two numbers. X can only go to one y value, so that is not a function. If we look at B, that is a function because each x goes to one y value. That last one is a function because each x can go to one y value. Now, different x's can go to the same y value, but the same x cannot go to two y values. Okay? There's a way to check this, and it's called the vertical line test. So basically, you draw a vertical line, and if it crosses more than once, it is not a function. If it only crosses one time, it is a function. So this one only crosses once, so that is a function. This one crosses twice, so it's not a function. This one only crosses once, and we can double check at different points in there, but it only crosses those once, so that is a function. Okay, now explicit equations, that's like y equals 2x plus 7. It's solved for a specific variable. Implicit, or yeah, there's some different examples also. Implicit means it's not solved for a specific variable. So x squared plus y squared equals 12. Y squared plus 9x equals -4. Xy minus 3 equals 15. Those are all implicit. Okay, so for the directions for this, we want to write it explicitly in terms of y and then determine whether it's a function by graphing on your handy dandy calculator. So this is where these graphing calculators are going to come into play. So I have x minus 4y equals 20. I need to solve this for y, so I'm going to subtract that x. -4y equals 20 minus x. Divide by -4. You get y equals -5 plus x over 4. I'm going to graph that in my calculator. That's the same as negative 5 plus 1/4 x, which is 1/4 x minus 5. It won't matter when you put it in your calculator. And you should get a graph that looks like that. Okay? And that is a function because it crosses the vertical line test. Look at this one. So we have x squared plus y squared equals 25. Subtract that x squared. So y squared equals negative x squared plus 25. Square root both sides. You get y equals plus or minus the square root of negative x squared plus 25. You always have to put that plus or minus. Then when you graph this, you have to put positive square root of negative x squared plus 25 and negative square root of negative x squared plus 25. This does not cross the vertical line test, so this is not a function. Okay, that's actually an equation for a circle with a radius of 5. Okay? You can do r. You should get plus or minus the square root of x plus 3 minus 1, and it's not a function. Now let's look at this one. I'm not sure what number this is or what letter, but you got it, I'm sure. I'm going to subtract that 1/2 x over, and I get negative cube root of y equals negative 1/2 x plus 7. Divide that by negative 1, and you get the cube root of y equals 1/2 x minus 7. Cube both sides, and you get y equals 1/2 x plus minus 7 cubed. Graph that, and that is a function. You could do t. You should get x minus 8 squared minus 1, and that is a function. Okay, let's look at this one. This one's a little bit trickier. You guys can do it, though. So I have xy minus 5y minus 1 equals 2x. We want to get all my y's to one side, so I'm just going to get rid of that 1. So I get xy minus 5y equals 2x plus 1. And I'm going to factor out a y on the left side. So I get y and x minus 5 equals 2x plus 1. Divide by that x minus 5, and you get y equals 2x plus 1 over x minus 5. Graph that in your calculator, and that is a function. Okay? Now, an equation, if you have y equals 3x minus 2, or minus 5, function notation is really just adding the f of x in there. So f of x equals 3x squared minus 5. And that's read as f of x. Okay? So to evaluate, you just plug in the value given to you. So say you have f of x equals x squared minus 6x plus 23, and you're evaluating an f of negative 5, just plug negative 5 in. And I would just put that into your calculator. We have them, so let's use them, right? Utilize them, yet, and you get 78. Same thing here, plug in 9, you get negative 74. Okay? Remember to take the quiz. Thank you, guys. Goodbye.